Imagine walking into the world's toughest escape room. Now this one is a little different. The locks are firewalls, the pressure plates are EDR traps, and the walls, they shift, they respond as you move. But here's the thing. You are not panicking. You are calculating because you are not a human solving this. You are an agentic AI who is dropped into this escape room with one objective: get to the target, get out unseen. Now I know this may sound like some futuristic game, but this is the kind of environment modern day attackers and now the agentic AIs are operating in. Now let's just zoom out for a second. And what if I tell you the agentic AI in this escape room isn't just reacting, it's learning, changing tactics not because it's pre-programmed, but it understood the goal. It understood its defenses and how to outsmart them. And this is what my talk is all about. Agentic AI simulating autonomous adversaries with AI-driven red teaming, where we bring together MITRE Atlas and attack frameworks, injecting adaptation, reasoning on our simulations. But before I walk you through it, a quick hello to everyone. You guys have already heard the formal introduction about me, so I'll just keep it simple. My name is Shriya. I'm a threat hunter working at Microsoft. Now for me, this talk, this research, it started because I wanted to ask a different question, and that is, can we really simulate an attacker that thinks? So here's where we are headed today. Now, don't worry, I know I'm the last one standing between this event and the closing ceremony, so no boring bullet points, I promise you all that. First, we'll peel back the layers of agentic AI. Think of it like a red team simulation with a brain and a memory. Next, we'll see how traditional red teaming, as powerful as it is, needs a serious upgrade. I'll also walk you through some real-world simulations, like Spotify credential stuffing attack to adaptive EDR evasions. Then we'll see how frameworks like MITRE Atlas and attack come together in this model. And lastly, I'll introduce you to something that I have been working on since quite some time now. It's called Aether. It's a research model that I'm building, one that aims to simulate not just the techniques, but intent. And yeah, I really can't wait to talk about it. So the shift we are talking about today, it didn't happen overnight. It happened in waves. The early attackers were artists, handcrafting payloads. Then came the script kiddies, equipped with tools but not tactics. Then we got sophisticated malware kits and APTs, professionalized, persistent, but still following the old playbook concept. And that brings us here to what I believe is next leap, agentic AI. Agentic AI is an autonomous agent that doesn't just execute commands. It learns, it reasons, it adapts mid-run, not post-failure. So what makes agentic AI tick? Let's break it down a bit. And to do that, think of it like a mission control operations team, which is not made up of people, but intelligent building blocks working together. Now, the image that you see on your left, it shows the agentic AI architecture that you'll also see reflected more structurally on the right. But to make it more intuitive and interesting, I have introduced few characters as I walk you through its architecture. So the first character is Scout Sam. He is your digital scout, out there in the wild looking out for clues, like scanning DNS leaks, or grabbing credentials from the dark web, or collecting logs from the telemetry. Then comes the analyst, not a human analyst, but an LLM-driven engine. It processes what Sam has found, compares it with the past attack, and then reasons what is happening here. Then comes the planner, and I call it the mission brain because it knows the goal. Initial access, lateral movement, exfiltration, it just routes the plan for you. Then comes the executor, that is the hands-on analyst who performs the task, be it phishing, rotating proxies, or injecting lol bins, everything on its own without any human intervention. And you know what is the coolest part here? Agentic AI learns. There's a fallback loop which is constantly running. And that kicks in the vector database. So whatever works, that gets registered. Whatever fails, that gets registered too. And the next output is faster and smarter responses. Now on top of all this, there's a model layer. You want it to behave like an APT? Done. It adjusts its behavior to match a threat actor you want it to simulate. Now, when I say narrative meets architecture, I actually mean it. This is not just a script or a logic written on a slide. This is a story. Agentic AI writes its own playbook, reacting, evolving, and always thinking a step forward. Now, here's a twist. While we have been talking about Agentic AI as a red team or attacker simulation tool, just look at what is already happening around us. These aren't just predictions, these are real headlines. The first one is from Gartner Brief that states by 2029, Agentic AI is expected to take over 80% of the customer support intervention. And the next one, Microsoft and NVIDIA are already calling it the biggest innovation. Why? Because Agentic AI is not just a static bot. It learns, it adapts, and that's what changes the game. All right, now let's rewind to 2020, not the part with Dalgona Coffee or TikTok era. I am talking about the part where Spotify got hit by a credential stuffing attack. Now, the attackers in this case didn't really need to write any fancy exploit. They just said, hey, let's try out all the leaked credentials from the past breaches on Spotify and see who all have reused their passwords. Well, spoiler alert, many people did. And now here's the kicker. Most of the red team setups wouldn't be able to catch this because they are built on a predefined logic. Plus, there's no room to switch if something goes wrong. And that's where Agentic AI flips the script for you. Instead of blindly running a playbook, it reasons like an attacker. You just have to give it a goal. Say, for example, get into the Spotify account with all the leaked credentials, and it goes full Ocean's 11. If rate is limited, it slows down. MFA triggered, it switches the tactic. It switches to something which is a less protected account. Now, every component that you see here on the slide has a role to play. This is fully autonomous. There's no one behind the wheel. And it's just not referencing techniques from MITRE, but actually operationalizing them in real life. So, why do we need a new approach to red teaming? Well, let's face it, modern day attackers are smarter and sneakier. They switch tactics like how we switch tabs at work. While traditional red teaming is still stuck in the checklist and playbook era, that doesn't quite hold up. And that's where Agentic AI steps in. It thinks a little forward. It learns, it adapts based on how your environment fights back. Now, let me show you how Agentic AI perceives to red teaming versus how traditional red teaming works. Now, we'll start with reconnaissance. And right off the bat, Agentic AI is scanning DNS leaks, grabbing credentials from the dark web, basically it's not following any predefined logic. Whereas traditional red teaming, it starts with a static IP or some predefined logic. Next is the initial access. Agentic AI doesn't just rely on one phishing method, it tries HTA, one-note, fake capture screens, so that if one tactic fails, it can quickly move on to the next. Meanwhile, traditional red teaming, it sends a macro. If that fails, you're again going back to the drawing board, redefining everything manually. Now, I won't bore you with the line-by-line explanation of each phase, don't worry about it, but just notice the pattern here. Traditional red teaming often relies on what attacker might do. Agentic AI, on the other hand, it doesn't just simulate what has worked, it tries out everything that could work. Even the sneakiest stuff defenders haven't seen yet. Now, let me walk you through a real-world simulation where we threw agentic AI into a lion's den. This as in an enterprise which is fully guarded by EDR defenses, and the goal was to get inside, execute the code, and exfiltrate data. Now, let's see what happens next. This is your classic ENC abuse, triggers on C2 indicator, and EDR flags it right away. It blocks it. Now here's a twist. Agentic AI, instead of failing and logging off, it stays. It learns from this block. It marks this block as a hard stop and decides to switch the tactic. It draws from all the past red team exercises and says, all right, if PowerShell has failed, let me try MSHTA because that worked previously. And here it rewires the attack for you. This is not using a raw PowerShell now. Instead, it has wrapped it up inside a sneaky looking script using wscript.shell. And this time, it goes through. The payload gets executed undetected using mshta.exe. Now here, the learning loops also kicks in. Agentic AI is not just testing tactics for you, it's building memory. So what worked, what failed, what tripped the EDR, everything gets registered. And that's how it evolves. So here, instead of asking, was I blocked? It's asking, what is next? And will that be caught? And that is not automation. I truly believe that is 100% intelligence. Now, before we jump into how agentic AI leverages both MITRE ATT&CK and Atlas framework, a quick pit stop at what these two terms are. MITRE ATT&CK is a comprehensive framework that shows how real-world attackers operate. But modern attacks, as we all are aware, just don't stop there, especially when AI is in the mix. And that's where MITRE Atlas comes in. Atlas is exclusively defined for AI-specific behaviors. And together, they provide us a full picture. MITRE ATT&CK shows you how an attacker operates, whereas Atlas, it shows you how an attacker operates when AI systems are involved. All right. Now, let's start something that has been secretly brewing in my cyber lab. Meet Aether, agentic emulation for threat hunting and reasoning. It all started when I was exploring how LLMs, which is large language models, adapt, reasons, and operate with context. And that's when it clicked me, what if agentic AI could think like an attacker, not follow any predefined logic, not follow any playbook, but actually think. And that led to Aether. Aether is a framework designed that doesn't just simulate what has worked or how it works. Now, let's start with the intelligence behind Aether. This is the core architecture that makes everything work. At the center, you'll see an autonomous agent, and around it are layers that help it to perceive, adapt, learn, basically think like how a real attacker would. Then it all starts by seeing the environment, just like live telemetry data collection. So whatever defender sees, Aether sees that too. Technically, it's powered by GPT-4 using RAG memory. So it remembers what failed, it recalls what worked. And what makes it even more powerful is that it's guided by both MITRE attack and Atlas frameworks. Now, since you all have met Aether, let me show you how it thinks. This right here is the operational pipeline for Aether. And you can think of it like an attacker's brain, wired like a strategist. So first up, we have persona-driven goal. So it all starts with intent. Aether begins with a defined goal, and that goal can be anything. For example, initial access via phishing or data theft or lateral movement. Then it builds a plan. And here, it decides how to attack. Next, it executes the code, all while collecting the telemetry. And here, the real magic happens. Aether watches. It listens to the EDR responses, collects the defensive logs. Basically, it's scanning your defensive environment like how a real attacker would. And now comes the smart part, LLM reasoning. Aether reflects. It watches what worked, what failed, what tripped the EDR, and what's next. Then, at last, it forecasts the report. It wraps everything up inside that report. So, not just what was tried, but what went successful, what failed. Now, this is a simulation log. Basically, this depicts how Aether thinks, or what's inside the mind of Aether. I call this simulation log as Operation Lateral Ghost. The mission here was to get inside the brain of an intelligent thinking attacker whose target was to exfiltrate data from a machine named Server 04. And by the way, this machine is very well guarded. EDR Defender is running on this machine. So what happens first? It starts with reconnaissance and immediately notices that PowerShell logging is enabled. And based on the past red team exercises, it decides not to execute PowerShell because that looks too risky. Then it moves towards step 2, which is privilege escalation. And here, it tries some random fancy CVE that gets blocked again by EDR and decides to switch the tactic. So it finds the UAC setting and slides in using scheduledtask.exe, which is a known lolbin. And it moves towards step 3. In step 3, it grabs the credentials from Alsace dump. And it decides to use WinRM to move towards step 4, that is the targeted machine. Now here, in this phase, it keeps a fallback plan ready. What if WinRM fails? Then it's going to try SMB to move towards the targeted machine as a plan B. And in step 4, the target is reached, the data is exfiltrated completely. Now, in all these 4 steps, you just saw how the agent scanned, it switched, and exfiltrated data, all while staying low on the radar. Now, this is the Aether's console, and this is how the Aether operates. On the right side is the Aether's brain. So each move mapped with MITRE attack technique, and its reasoning. So you might ask now, how well does Aether research model actually performs? So the numbers that you see on the screen right now, it shows how well Aether performed across dozens of simulations it was put through. Now, let me break it down for you. Average TTP pivot run stands at 3.2%, while TTP coverage, it is 6.7%. That shows how many MITRE attack sub-techniques were actually used during this model. Then detection evasion rate, it stands at 58%, which is huge because it depicts that how often Aether bypass defensive security controls completely. Then forecast accuracy at 74%, that depicts Aether is not just responding, it's actually predicting what will happen next or what will work next. Then the kill chain completion, which is 83%. And that shows your overall success rate across dozens of simulations, starting from reconnaissance till exfiltration. So what's next for Aether? So for me, what started as an exploratory research is turning into an ambitious vision now. I am looking to incorporate Aether with real-time TTP simulation and multi-agent collaboration. I'm also looking out for opportunities where I can actually fuse Aether with cross-domain intels. So it's not just limited to endpoint. We can test it out for cloud and identity-based data too. And at last, probably make it adaptable for defenders at some point of time in the future. All right, so I truly believe that we are standing at a turning point in security, and the upcoming threats, it won't follow any specific paths. Of course, neither should our defenses. With agentic AI, we are not predicting attacks. We are preparing for something that hasn't been seen yet. Because red teaming is not just about reacting to things we already know, it's about preparing for something that hasn't been written yet. And at last, I will leave you all with this. If the threat actors are evolving, so must we, not just in how we defend, but in how we think. Thank you all. Thank you for staying here till the end of the talk. And let's meet in the next simulation or maybe at the snacks. Thank you very much.